I'm assuming that you've seen line equations before, okay? All right, so you probably have seen that y equals to mx plus b is the equation for the line, right? Anything that looks like this will should have a graph that's a straight line on the plane. Let me ask now, what is m? It's called a slope. What is b? It's the y-intercept. And this slope, you have a formula for it. What is it? What is it?
Is it y2 minus y1?
y2 minus y1 over x2 minus x1. Okay. So that's the formula for the slope, but because this course is a pre-calculus course and I want you to be more ready for the calculus course, let me write it slightly differently. I want to write it as change of y over change of x. Change of y over change of x, where this change of y, this is a change of y. And same thing for delta x. This is change of x. Before I try to explain what this means by change of something, let me first point out that I read this as delta, right? This is actually an alphabet. Alphabet of which language? Greek. It's a Greek alphabet. And what letter does it correspond to in English?
B.
D, right? So this is a Greek capital D. That's what it is, right? And then now the question is, why would, out of all kinds of letters, why would people use delta? Delta is D. D stands for? Not distance.
Difference.
Difference. Very good. Yeah, it's for difference. Okay. So delta y is a difference of y. Okay? Difference meaning you have to subtract 2. Okay. So that's why people use this delta. And later in the calculus course, you'll see that delta y over delta x would converge to something called dy over dx when you make these quantities very, very small, and that's called the derivative. But that's an entire week of class, so I can't really explain that. But coming back here, let me try to explain what change is in terms of a simple example. So let's say today I have in my bank account $100. I know I'm poor. Okay, I only have $100. But on the way back, I buy something, and now tomorrow when I wake up, I only have $50. Okay, what is the change in my bank account? Is it plus 50 or minus 50?
Minus 50.
Okay, how do you get that minus 50? Subtract. So which way do you subtract? Do you do 100 minus 50 or 50 minus 50? No. If you do 100 minus 50, you get positive 50. That would mean that my bank account grew by $50, which is not true. It decreased by $50. So to actually get negative 50, you need to do what? 50 minus 100. That's the true change. Do you agree? Okay, I'm trying to make an important point here. If you want to know the change, you better be doing the final value minus the initial value. Or terminal value minus the initial value. That is the change. That's the change, delta. That's the difference. Okay? So, now let's go back to this question and try to solve this with the formula I have on the board. And I will like to show you two solutions. So this will be the first solution. And the first solution does this. Think about the very first point as x1 comma y1. Every point has an x-coordinate and a y-coordinate, right? And then the second point as x2 comma y2. You get that? Okay, now what is the change in y then? Is it -1 minus -5 or -5 minus -1? -5 minus -1. So you have to do -5 minus -1. Now, actually, for this slope, you could reverse it, and because you're dividing things, at the end of the day, you end up with the same solution. But since this concept of change appears in so many places in calculus, and also in physics as well, it's good to have it right the first time. Always make sure that you're doing terminal value minus the initial value, right? Okay, and minus minus is plus, so it's going to be -5 plus 1. What is that? -4. Now let's think about the change of x. What's change of x? What minus what? 3 is the terminal value of x. 1 is the beginning value of x, right? So you're going to do 3 minus 1, which is 2. Okay, that tells us what the slope is. What is the slope? M is change of y over change of x, which is -4 divided by 2, which is -2. Okay. So we got the slope, which means we can take this formula that we're given, this is the line equation, and happily replace this m by -2x plus b. And that immediately tells us that the next thing I need to figure out is the b, which is the y-intercept. We have to figure out the y-intercept. And the idea is this. If you know that 1 comma -1 is on this graph, think about how we draw a graph when you're given an equation. So suppose you're given like something like y equals to 5x plus 7, something like this. How do you draw a graph? You make a chart of a table of x and y values where x is like -1, this will be 2, and then 0 will be 7, something like this, right? And you keep plotting this, and then eventually you end up with a straight line if you do many values, right? And if you think about this process, what it's really saying is that any value that you plug in for x on here would give you the y value on here. And in our case, if this is on the graph, it will be like this. Hypothetically, let's say you did know b. Then how would you draw it? You would have x and then y values, and when you had 1 over here, what would you be getting? -1, right? So you know that when you plug in 1, you better get -1 for the y. Does that make sense? Okay, so that's what we're going to do. We're just going to take this x1 and y1 and plug it into x1 and x into here and then y into here. So y has to be -1 equals to -2, 1 plus b. Right? -2 times 1, anything times 1 is itself, so it's -2 plus b. Add to both sides. And what's 2 minus 1? 1 equals to b. And therefore the final answer is y equals to -2x plus 1. This will be the equation of the line passing through those 2 points. Okay? You probably have seen this before, right? This is more like a review. Now, let me pose a question before I show you the second method. So here's a question I want to ask. How do you know that 3 comma -5 is also on this graph y equals to -2x plus 1? How would you know? Yes? How would you know? how do you know that 3 comma negative 5 is also on this graph y equals to negative 2x plus 1? Yes?
You plug it into the y.
Yes, again, it's the same idea. It's the same idea. If 3 comma negative 5 is indeed on this graph, then when you plug these numbers in here, then the equal sign should hold. So let's see if it does work. You plug in negative 5 into y, and you're questioning whether this equal sign is true. And on the right side, you have negative 2 times 3 plus 1. What is this? This is negative 6 plus 1, which is negative 5, right? Oh, negative 5? Negative 5? Check. It does work. Done. Okay? So we do know that, and this is significant because it verifies that indeed this equation satisfies the condition given us. We already know that it passes through 1 comma negative 1. We now know that it passes through 3 comma negative 5. Now think about this. If you're given 2 points on the plane, how many lines pass through those 2 points? Just one line. There's only one unique line that's going to pass through both points, right? So because we found a line that passes through both points, this has got to be the answer that this question is asking for. Is that good? Agreed? Okay. So if you have this in mind, now I can give you the second solution. And the second solution makes use of a different formula. Solution 2. This one is called the point-slope form. Y minus, oh, by the way, this one is called a slope-intercept form. Because it uses a slope and an intercept, okay? And then this one, I'm writing down as the point-slope form. And the formula is y minus y1 equals to m times x minus x1. Sorry, it's getting a little loud out there. Okay. So how do you use this? Well, first of all, you do the same thing for the slope. It's nothing different. Slope is change of y over change of x. And this is always terminal minus initial, so negative 5 minus negative 1 over 3 minus 1. So that part is exactly same as solution 1. So this is going to be negative 4 over 2, which is negative 2. That part is not different. But then, you just take the x1 and y1, plug it into x1 and y1, and you do not plug anything into x and y. You leave x and y. You don't. If you plug in something into x and y, then that's wrong. Okay. So the way you use the point-slope form is you only replace x1, m, and y1, and don't touch the x and y. Okay. So we have y minus y1. What do I use for y1? Negative 1. What's m? We just found that to be negative 2. And then x minus? Nope. 1, right? 1, right? It's x1 is 1, y1 is negative 1. So it's 1. Okay. So that's the answer. But you still need to simplify it, and then you write it as y plus 1 equals to negative 2 gets multiplied negative 2x. And then negative times negative is positive, so it's plus 2. And now you subtract 1 both sides, and you get y equals to negative 2x plus 1. Okay? So you get the same exact answer as the first one. Now, some discussions. How do you know that this equation right here, this one right here, passes through 1 comma negative 1? How do you know that 1 comma negative 1 is on this graph? Yes?
Because 1 minus 1 is 0.
Yeah, if you plug in 1 over here, 1 minus 1 is 0, so you get 0 on the right side, and then?
And then just
You plug in negative 1 here, and what's negative 1 minus negative 1?
0.
Anything minus itself is 0, right? So what does that verify?
0.
0 equals to 0. So the equation holds, right? If 0 is equal to 0, the equation holds, and we know for sure that this is a point on this line. Okay? Furthermore, what's the slope? Well, if you multiply it out, eventually negative 2 is going to be the coefficient of x, right? So this negative 2 will be the slope. So if you look at this formula, already it makes sense. This will be a line which will pass through this point, and it will have exactly the slope that's negative 2. Negative 2 slope goes like this. Now, if you provide a point and a slope, there's only one line that matches that description, right? So that's why this gives you an answer. Okay? The reason I'm explaining this is because many of you take this as some really complicated formula that you have to memorize. But it's not. It's kind of obvious. It's obviously this. Why? Because having y minus y1 and x minus x1 already tells you that, oh, this line equation is going to pass through x1 comma y1, right? If you plug in x1 here and y1 here, they're going to give you 0 equals to 0. So it passes through x1 and y1, and then it will have the slope m. What else can it be? It has to be the line that passes through x1 comma y1 with the slope m. That's what it's saying. If you can look at this equation and think that way, there's nothing to memorize. It's just obviously just saying 0 equal to 0. That's what this is saying. Is that good? Which one would you prefer? The first method and second?
Close.
Okay, so how many of you say first? You would use first. How many of you say second? Okay, well, it doesn't matter as long as you get the correct answer, you get full credit. But however, I have a motivation to sell you the second method. The reason is, this becomes a lot more important when you get to calculus. And because this is a class for preparing people for calculus, I need to push for this. And because of that, what I would do for my exams, or for online homeworks, often you have to do this. But for my exams, if I say find the equation and I have something like this, then you can just stop here. And I wouldn't even care if you make a mistake afterwards. If this is correct, I'll give you full credit. Okay? So that's a big motivation to using this one over the other one. Okay?